Hello.
老师，我们听不见，没有声音。
是啊，就听不见，只能看得见你画的画。
是的，
我也听不见。
是不是大只猪听不见呀？
他不在说话，他听到我们，也许我们不听见了。
Okay. All right, I'm going to use another computer just connected. Okay, now it's okay, right? Can you hear me now? Hello?
Yes.
听得见，
可以听到了，可以听到了。
但是你的
Okay.
网可以听到，但是
听见你啊。
Okay, great.
好像你有点不好。
对，但是我临时换了一个电脑的。Okay, all right, that's it. So we can do change it next time. I actually test the computer. Really. Okay, so let's start the class. All right, so we're going to discuss several problems. Those are the story problems. Okay, now to solving story problems, we should draw the picture first. Okay, don't just work on script. When you draw the picture, you will see that you notice that there are 25 sections there. Okay, and the length of each section is 2 meters. Then the total length, right? You know that's going to be 25 times 2, it's a 50. So that is the length of this whole line. Now, if you don't draw the picture, some students will, not everybody, okay, will do the multiplication 26 times 2. Okay, then that is a mistake. Okay. So for solving word problems, first step is always trying to draw the picture, okay? Even it's not a geometric problem, you still can draw the picture. Then you look at the picture and look at the information, and maybe you can figure out the best way to solve the problem. Okay. All right, now let's take a look at the second problem. Okay, 10 balloons in red and yellow colors are hanged in a row. Red balloons appear in pairs, and every 2 red balloons, there is a 1 yellow balloon. Okay, between every 2 balloons. Okay, how many yellow balloons are there? Okay, so it's between red balloons appear in pairs. Okay, they always connect together. Okay, now that's the first requirement. That's the first requirement. Okay, so every 2 red balloons, between every 2 red balloons, there's a yellow balloon. Okay, so I should add word. Okay. So that's a assumption. Okay. Now you definitely have to draw pictures, right? And not just write down all the possible patterns. Then you can solve the problem, right? So you can begin with, there's a 2 possibility. You know, just the 2, maybe one of them is not possible. Okay. So you begin with a yellow brown, right? Yellow, then red, red, okay? Yellow, red, red, okay? Right? Then yellow, red, red, and yellow, okay? So you will see that they already got 10, right? So then there'll be 4 yellow balloons there. So your conclusion is a 4 yellow balloon. Okay. There's another possibility. It begins with the 2 red balloons, right? And the red, yellow, red, red, yellow, red, red, yellow. Then it begins with the red. But then that's only one, because it's already 10 here. But it says that red balloons appear in pairs. You cannot just have only one. Okay, that's impossible. Okay, so the only solution you have here is, there are 4 yellow balloons. That's the first pattern. The second pattern is excluded. Okay, there's 2 possible patterns here, right? You notice that the 2 possible patterns. So this is so you divide, you're trying to figure out how many different possible patterns, then write down, all the letters. Okay, Y means yellow, red, R means red. And then you can quickly see, okay, only the first pattern is possible. And from the first pattern, you can figure out the 4 yellow balloons. Okay, that's it. All right, so now I'm going to ask you to do the next problem. Okay, this time it's not a line, it's a circle. Along a circular pool, every 6 meters I put a flower, because there are total 14 flowers. What is the parameter? Okay, this is another geometry problem. Yeah. Now, you have to figure out the way to do that. Sometimes, we may have many flowers. You cannot even draw them. So I have 140 flowers, for example, right? So we have to find out the way to solve, to count. Okay, so you look at, this is part of that, right? You look at this. I do have some students have given me the answer yet already, and this is the correct answer. Okay, so between 2 flowers, okay, right, there will be 6 meters. The distance. Okay, that's 6 meters, the distance. Right. So the question is, what is the parameter? Okay, I got 2 different answers now. Okay, I got 3 different answers. So that's what we have to think about. Okay. Yeah, it sounds trivial. So you begin with you maybe do some multiplication, you probably make mistakes, right? So you begin with, let's begin with the 3 flowers. Okay, let's begin with 3 flowers. Suppose you only have 3 flowers. If it's too complicated, you cannot draw all the flowers. Just look at the case. Yeah, some example. Okay, if you have 3 flowers, right, it's easy to see, right? The distance between 2 flowers is 6 meters, 6 meters. Now, what is the parameter? 3 times 6, so 18. Okay, see, just 3 times, right? So if the number is too large, what you should do is don't just work on the larger number. You can look at the small number first. Yeah. Just assume there's 3 flowers or 4 flowers or just 2 flowers. Okay, then you get, then it's easy to see, you will definitely come up with correct answer because you can count. Okay, you can count, right? So if there are 4 flowers, okay, 1, 2, 3, 4. And you see that you have 4 sections. If there are 4 flowers, you have 4 sections. Right? 4 pieces here. So that's why the parameter is just 4 times 6, okay, 24 meters. So now you get the ideas. All you have to do is just multiply, okay, the number of flowers by 6. Okay, the number of flowers by 6. So the answer here, if there are 14 flowers, okay, just 14 times 6, that gives a parameter, which is 84. So something given 90, 96, 124, they're all around. So, okay. Yeah. It's I cannot plot 14 flowers around the circle. Just too many. Okay. It's harder to do that. But I can do that, you know, just for if we are given 3 flowers or 4 flowers. I can figure out the parameter based on the information. Okay. Okay, got it? Yeah, if you're dealing with a very large number, like I have 1,400 flowers, it's impossible you can plot them, right? So there's no way you can do that. Okay, then how do you figure out the parameter? So you begin with a simple, smaller number and get some ideas. Then you get general. Now, if you can also do this, that's a little bit harder to, you know, do that. The first flower, you go to the right about 6 meters. Second flower, 6 meters. Okay, third flower, you know, just count the measure the distance from that on the right from that, flower. So it's have a 14, then you measure this, right? Total. So actually you have a 14 flowers, and you have 14 pieces here. That's why just 14 times 6 give you a total parameter. Okay, so this is a tricky problem. All right, so now let's do the next problem. So I have a larger number here, right? I do have a larger number. It's 101 trees are planted along the 250-meter long street at the equal distance. So there's a tree at each end of the street. Okay, so there's 2 ends of the street here. Okay, so this is a tree. This is a tree. Okay, I cannot draw 101 trees here. Okay, it's impossible. The number is too large, right? So the question is, what is the distance between two nearby trees? Well, this time I'm not trying to find the distance between the length of the street. Okay, I'm trying to find the distance between 2 nearby trees. Okay. All right, so the question is how many sections you can have, right? Yeah, go on, you know, if you figure it out, right? My hint is you have to figure out how many sections, how many pieces here, so many pieces, right? Right. You have 101 trees, including 2 endpoints, right? So that means you have the number of the gaps between trees, right? So the number of gaps or intervals, right, is going to be 100. Okay. The total distance is 250, right? So the distance between 2 nearby trees is going to be 250 divided by 100. Okay. So the total length is 250. And you have 100 sections here, right? 100 sections, right? Then the length of each section is 250 by 10. So the length of each pieces, each section, okay, is going to be 250 divided by 100. It's 2.5 meters. Just to Yeah, it's not 25, 200. Yeah, 2.5, because you have 100 sections here. Right? Total length is 250. Okay, got it? Yeah, that's just division. Now, if you draw the picture, I think that the picture helps you to understand the problem. Okay, so you just need to figure out how many sections here. You cannot draw 100 sections here. You cannot plot, you cannot draw, 101 trees here. There's too many. Right. All right. So the next problem, I want to do that. I give you enough time. Okay. So 320 flowers are arranged in 8 rows, and the distance between 2 nearby flowers in each row is 1 meter. How long is each row? Okay. Again, you should draw. You should draw 8 rows, like draw the lines, pieces, right? So my hint is you have to figure out how many flowers in each row. Okay, after you figure out the numbers of flowers, then you figure out the number of the section, whatever, it's all gaps between 2 trees, right? Okay, so let's draw that. So we have we have many rows here, right? 1, 2, 3, 4, 5, 6, 7, 8. So the number of flowers in each row, right? Okay, is going to be 320 divided by 8. That's a 40. So there are 40 flowers. But 40 flowers include 2 endpoints. So the gap, okay, the number of gaps, right, or sections, right, between 2 trees, right, is going to be only 39. Because you have 40 trees, but you have to subtract 1, okay? Only 39 gaps. Now, the length of each row, that depends on the length, the distance between the length of each gap, right? So the total length of each row, the length of each row is going to be 39 times 1 meter, because the length of each section is 1 meter. So that's why it's 39 meters. Okay, 39 meters. Right, so it's just, this is a 2-step problem. It's not just like 1 step, you do the multiplication, division, and solve. So you have to solve, in order to figure out the length of each row, you needed to figure out how many gaps in each row, right? Then you have to figure out how many trees in each row first. That's why you have to 320 divided by 80 divided by 8. That's a 40 trees. Okay. Then you can figure out how many gaps, right? So step 1 to solve story problem, draw the picture if possible. That helps you to analyze the data. Okay. Then breaks the problem into several steps. Okay. Okay. Yeah. So yeah, you have still, you cannot plot 40 points along a line. Just still too many. All right. So now next problem. A piece of wood has 16 meters long. Okay. it is cut into 8 pieces of equal length. How many cuts should be done? So a piece of wood, right? And draw the picture. Okay. Cut them into 8 pieces. Okay, so 8 pieces. So 8 pieces, you know, you label it, right? 1, right? 2, 3, 4, 5, 6, 7, 8. Right? So how many cuts should be, right? And it cut 8 pieces of equal length. Then you will see that you just need the 7 cuts. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, the length of each piece, you can also figure, right? The length each piece, can you figure out, right? The length of each piece, how many cuts should be, right? And the length of each piece is going to be 2. Right? You can also even figure it out, right? Should I find out the length of each piece? No. It is cut into 8 pieces of equal length, and how many cuts should be done? Just 7 cuts. Okay. All right, so take a look at the next problem and try to do it by yourself, okay? All right, so I do get several different answers here. Okay, please post the answer to me only. Don't show to anybody else. Okay, Essen. Michael Zhu, do you have answers?
Not yet.
Okay. Can you close your video? I can see you. Thank you. I think you should draw kind of pictures to help you. I do have I got one correct answer from Albert Zhang. Yeah, how to post answer to me only, just check my name was a host next, let's say host. Click my name and then post answer, okay? Don't post to everybody. Maybe your answer is wrong, maybe you're sometimes misleading, okay? Or disturb other students work on the problem. All right, so 7, so let's see, what cut a piece of steel bar of 30 centimeters long into several pieces, okay? Into several pieces, by each piece 5 centimeters long, okay? So question is how many pieces you're going to get. So the number of pieces, right, is going to be total is 30, right? 30 centimeters long. The number of each piece. Okay, the number of the pieces is going to be 6. Okay, right? So once you get the number of the pieces, right? Once you get the number of the pieces, then you can figure it out the number of the cuts you're going to do. Right? You have 6 pieces, remember, right? 6. No, 1, 2, 3, 4, 5, 6. How many cuts you're going to do? 5. So the number of the cuts is going to be 6 minus 1 to 5. Okay. So for each cut, it takes times, right? 4 minutes. Right? So the number of minutes you're going to spend. Right? Not times. I'm going to, yeah, the total time. Right? Is going to be the number of cuts times the time you're going to spend on each cut, which is 4. So it's 20 minutes. Clear? So this is a 3-step problem, not just 2-step. In order to find the time you're going to spend, you have to figure out how many cuts you're going to make, right? In order to figure out how many cuts you're going to do, you have to figure out how many pieces you're going to cut. Right? Backward, step by step, right? Okay, so I do see one answer is correct. Yeah. I think how do you get a fit 30 minutes? Right. Okay, now it's clear, right? I hope I understand. Yeah. Still, there are some students cannot figure out the relationship between number of cuts and number of pieces. Number of cuts is going to be number of pieces minus 1. Okay. All right, so the next problem. Trees are planted along a street at equal distance. Joe walks at a constant speed. It takes 20 minutes to walk from the first tree to the 6th tree. So from here, you can figure out speed, right? You know that, right? How many trees it's passed. Okay, so you figure out speed. So if John continues to walk for 24 minutes after he passes the 6 trees, which tree will John reach? This is also several step problem. And please draw the picture, okay? At least for the first 6 trees. You draw the picture and you figure out the speed, how much time he spent for passing each tree. Okay. So now I have 3 different answers, unfortunately. All right. The 3 different answers, no one of them match my answers. Okay. Angelina, don't guess. Okay. You just say this is how do I get it, right? Okay, I'm waiting for correct answer. I do got different numbers, 12, 15, 16. That's lots of them, okay? And even more than that, and it's going up, yeah. So all kind of numbers between 12 and 18. Okay. All right, so let's draw the picture. So this is the first piece, right? 1, 2, 3, 4, 5, 6. 6 trees here. They agree, right? So 6 trees. Joe walks at a constant speed. It takes 12 minutes to walk from first tree to 6th tree. So 12 minutes. 12 minutes. Okay. Right, 12 minutes for how many sections? 5 sections. 12 minutes, 5 sections. Right? Actually, here 6 trees, but there are only 5 sections, 5 gaps. Right? Now, he continues to walk for 24. 24 is just the double of the 12. So one piece, another piece. Right? 12 minutes, 12 minutes. Okay? So this is a 6th one. Can you still some student can get Michael? Your answer is wrong. Okay, so it's not like a okay now. Okay, it's actually forget the first tree. 12 minutes. He passes 5 trees, not the 6 trees. Okay, so actually 5 trees. 1, 2, 3, 4, 5. Right? 1, 2, 3, 4, 5. Right? So 1, 2, 3, 4, 5. Do you agree? Yeah. Forget this. We don't count the first one. Right? 12 minutes. He passes 5 trees. 12 minutes past 5 trees. So you have 12 minutes, 12 minutes, 12 minutes total, right? Okay. So it's going to be what? So this is six trees, right? So 8 to 5, so that's a 6. 6 plus 5 plus 5 is going to be 16. Right? So the 16th tree, not the 15th tree. So the answer is 16th tree. Okay, just add the 5 to 6, add another 5, right? So this is the 11th tree already. That's the 16th tree. Got it? Yeah, now it's clear after you draw the picture, right? So 12 minutes, it passes 5 trees. Forget the first one, the starting point, right? 12 minutes, 5 trees, 12 minutes, 5 trees. Okay, total he passes 15 trees. But add plus the first one, initial, right? That's 16 trees, total 16th tree. Okay. Yeah, you see, that's not that's not difficult. Do the computation is not difficult, right? Just do the addition, multiplication. So we should be able to, yeah, figure out the right method. Don't miss anything, you know. Yeah, sometimes you ignore the first one, okay? And you draw the picture, ignore the first one. You walk for example, the gap between two trees, let's say, assuming 1 meter, okay? 1 meter, right? So he walks 5 meters for 12 minutes, okay? Or you can also assume that, you know, 6 meters between two trees. So this is just assumption, then you can solve the problem. Okay, but anyway, the picture shows that you don't count the first one. 12 minutes, you pass 5 trees, 12 minutes pass 5 trees, 12 minutes pass 5 trees. So total, total, right? 36 minutes. It passes 15 trees. But including the first one, then that'll be plus the first one, that'll be 16 trees. All right, great. All right, so take a look at the next one. Students stand in 4 rows. Each row is 230 meters long. Okay, 4 rows, right? 1, 2, 3, 4. Right? 230 meters long. The distance between the students is 2 meters in each row. How many students are there? How many students are there? Okay, anyone got answers? I do have some answers. Okay, and I get 2 different answers. And then, so some students got 464, something got 460. Right. So let's see. So first of all, how many, okay, 260 meters long, right? So the gap between 2 students, 2 meters. So 230 divided by 2 gives you 115. Okay, that is the number of the gaps, right? Number of the gaps. But the number of students, you have to add 1. Okay, so the number of students in each row is going to be 115 plus 1. That's 116. Okay. Then the answer is the total number of students, right? Is going to be multiplied by 4. So it's going to be 464. Okay. Yeah, you have to add the 1 because those 2 students stand at the 2 endpoints. you figured out the number of the gaps, right? The number of the gaps or number of the sections, okay? So it's going to be 115, but you have to add the 1 to get the number of students in each row. Then you multiply by 4. Okay, so that is the answer. All right, so take a look at the next problem. A building has 8 floors. There are 36 steps from the first 18 floors. Yeah, sorry. So there are 36 steps from the first floor to the 4th floor. How many steps from the 4th floor to the 8th floor? Okay. Again, you should draw the picture, okay? Okay, anyone has answers? You see, again, I have 3 different answers at least. 36, 48, 27. Okay, only one of them is correct. Can you redo that, double check your work? Okay. All right, so in United States, the first floor is the ground floor, okay? That's the first floor. Okay, then and the second floor, all right? Third floor, 4th floor, okay? Then 5th, 7th, 5th, 6th, 7th, 8th floor, okay? Right, you draw the picture. So that's the second, that's the third, that's the 4th, and the 5th, 6th, 7th, 8th floor. Okay. So the number of steps between 2 floors is going to be the number of, you have to figure out that first, the number of steps between 2 floors is going to be from the 1st floor to the 4th floor. How many sections here? 1, 2, 3. So there's 3 sections. So that will be 12 steps. Once you figured out that, then you can solve the problem. Okay. So from the 4th floor to 8th floor, 1, 2, 3, 4. There actually are 4 sections here. Okay, from the 4th floor to 8th floor, there are 4 sections here. Okay, from here to here, that's 4 sections. There's 3 sections, right? So that's why. So the answer is going to be 12 times 4, 48. 48 steps. Okay, 48 steps. Total is 72 steps, right? 72. No, not 72. Okay. Total is 36 plus 48. Okay. that'll be 84. Okay. Right, clear? Yeah, draw the picture. And from the picture, I think this is the only way you can get, right? So first of all, you find the number of steps between two floors. Right? Between two floors, which is the 12 steps. Now, right? Then you just count how many stairs from 4th floor to the 8th floor. Right? That should be 4 stairs. That's why you have to multiply by 4. Okay? So after explaining to you, now you understand, right? So the question is, how do you, you're going to get a homework assignment. The problem is pretty similar. Okay? I hope you can get all correct in the first round, okay? And if you check the answer, you find the answer is different, then redo the problem by yourself, okay? But I think draw the picture that helps you to solve the problem, understand the problem, okay? So those are the problems we are discussing. I'm going to talk about, then I'm going to do some review, okay? So begin with, when we solve the problems, very often we're going to deal with the fractions. The so-called fractions, okay? You should understand the fraction is just the value is going to be the quotient, okay? The fraction, for example, 5, let's understand what does a fraction mean, okay? Fraction, here's general formula, A over B, okay? This actually is a value, is a quotient when A divided by B, okay? This really means the result, okay? If A is divided by B. Okay, so that means 4 over 2, that's just give me 2, okay? And 5 over 2, when you divide it, you can use a calculator or do by hand, it's a 5.2. So that's a fraction, okay? So conversely, a decimal can be also with repeating digits or just find too many digits can be changed back to the fraction. So fraction is just a number, okay? The value of this number is going to be, just the result or the quotient when you divide as the numerator divided by the denominator. The one on the top is called the numerator. The one at the bottom is called the denominator, okay? And sometimes you can simplify, sometimes you cannot, okay? For example, 12 over 8, right? 12 over 8, 12 divided by 8, 12 is not divisible by 8. You cannot get the integer, okay? 16 over 8 is 2, but 12 over 8 is not. So, but you can also simplify in the following way. 12, you can factor it, it's 3 times 4. 8 is 2 times 4. So there's a common factor here. That's common factor. This common factor cancels out, okay? Then you get 3 over 2. But if you want to change 3 over 2 to a decimal number, it's up to you. Sometimes we do, sometimes we don't want. Okay, in general, I just want to keep this fraction. It looks better than the decimal number. Okay, so this is 3 divided by 2 is 1.5. Okay, so that's a fraction. Now, fraction, you can also, in order to add a fraction, you have to make sure the two numbers have the same denominator, okay? And this must have the same denominator. If they both are B, then you get A plus C over B, okay? If not, you have to change, you have to make them to have the same denominator, okay? For example, 3 over 2 plus, okay, plus 1 over 4, right? And those two, you cannot just add 3 plus 1 because the 2 and 4 are all different. So very first step, you multiply by 2. This is the inverse step, right? You instead of simplifying, you make it more complicated. But the main purpose is to get the same denominator, okay? So that will be 6 over 4 plus 1/4, then you can add them together, 6 plus 1/4 by the above formula. Okay, it will be 7/4. Okay. Now, in elementary mathematics, when you 7 divide 4, you will get a quotient, which is 1, and the remainder is 3. So sometimes also written in the form 1 and 3/4. Okay, but I do not recommend this. Okay, a proper fraction is better because it's easy to be confused. It looks like 1 times 3/4. Right. So when you do the, yeah, so that's why I'm trying to avoid using this. But in elementary school, you still see this kind of mixed number. Okay, that's a fraction. Now, why we have to study fractions? Okay, sometimes we have to express it as a solution. Okay, if some number, okay, some number times 2, some number, right, times 2 equals 16. Okay, then you already know that, okay, so that number is going to be, that number should be equal to 8 because I know 2 times 8 is going to be 16. But actually what you do here, you can solve, this is easy, so you can figure it out by, directly, right, just by guess. But you can also solve the problem in the following way, that both sides you divide by 2. Okay, if you divide by 2, then this common factor cancels out. So you get only this box. Okay, so it's going to be 16/2. Now 16/2 is 16 divided by 2. So this time you can get an integer, so it's going to be 8. But sometimes you don't get, an integer. You can express a solution in the fraction form. Okay. Yeah, solution in the expression form. For example, 3 times some number, okay, is going to be 17, right? There's no integer. You cannot just by guess and trying to find the integer, so that 3 times that integer is going to be 17. There's no way. So what you can do is you divide the 3 times this, divide both sides by 3. The left-hand side of 3 is gone. And then the answer is just 17/3. Okay, 17/3 is a number. Okay, so 3 times 17/3 is going to be 17. So the solution is 17/3. Okay, so this is the number. Okay, so this is about fractions, and the way you use the fractions is sometimes you cannot avoid the fractions. Fractions basically is a number, the numerator divided by the denominator. Okay, now if there's a common factor there, numerator denominator, you can cancel those common factors. You can simplify the fractions. Okay, but when you add the two fractions, you have to make sure they have the common denominator. Otherwise, you cannot add them together. Okay. You must make them to have a common denominator in order to make them, add them together into one single fraction. All right, so now let's look at a famous problem. Every kid in the world have to study this type of problems called the rabbit chicken problems. Okay, so this is we have several ways to solve this problem. Now let me discuss this last problem. Okay, and what is the easiest way to solve? Right? You can figure it out. You can compare. So I'm going to ask you to do this problem. Okay, some of you already did that before, but trying to find 2 different ways to solve the problem. One method is more elementary, other method is more advanced. Okay, I begin with the elementary method, then talking about the advanced method. So please, please work on. I'll give you 1 minute. Okay, then I have 2 minutes left. Let me discuss. Okay. Anyone has answers? I have one answers like that. Emily, okay, Emily has another answers. Okay. Okay, so here we're gonna do, okay. So we have chicken has 2 legs, rabbit has 4 legs, right? So the number of the chickens, right? We assume that the number of the chicken. Okay, here's a number of rabbits. Now this method only works for small numbers, okay? So the number of legs, okay? And right now we have a 54 legs. Well, let's assume it. All of them are chicken, okay? 20 chicken, 0 rabbits, okay? Then how many legs are you gonna get, right? You're gonna get 40 legs, which is much less than 54 legs, right? So you have to decrease the number of chicken and increase the number of rabbits. But if each time the net change, okay, the net change, right? You're going to increase 2 legs, increase 2 legs. Okay, so keep it doing like that. Okay, it'll be 40 plus 2 times 2, right? And then 17 and the 3. So 40 plus 2 times 3. Okay, so the difference, when you lose 1 chicken, get 1 rabbit, you get total change in legs will be increased, the number of legs will increase by 2. All right, so finally you have to have 40 plus 2 times something, right? Okay, and that should be equal to 54. So you are talking about a equation here right now. Okay, so you both sides subtract 40 and 2 times this is going to be 14. So that number, you see, you have to do the division, right? It's 7. So that means you are going to, this 3, 3 corresponding to the number 3 here. So that means you are going to have 7 rabbits, okay, 20, that's a 13 chicken. Then have a 40 plus 2 times 7, it's a 54 legs, okay? This will be the last line you're going to have. Okay, that will be the last line you're going to have. Okay, so this is one method. That's an elementary method that people do. Another method they use is different. So then C means the number of the chicken, R means the number of the rabbits. Total, that will be 20. Okay, that's the first equation. Second equation is for each chicken, you got 2 legs, so you have numbers. You have a C many chickens, so that's 2, 2C. Then plus 4R. 4R means how many, 1 rabbit to get 4 legs. So that's total. So you get 54 legs. So this is a number of legs. This is a, so that will be 2 equations. And that is not easy to solve, right? Right? To solve this, you want to find the rabbits, right? So the idea, maybe you don't understand, but let me finish this, okay? So this is equation 1, equation 2, okay, using the equations. So the first equation, I multiply by 2. So I get 2C, 2R, and the 2 times 20 is 40. Okay, so that's essentially the first equation, but I multiplied it. I put the change a little bit. Then you what you get? Then you do the subtraction. 2C minus 2C is gone. 4R minus 2R is 2R. 54 minus 40 is going to be 14. Okay, then from here, R should be equal to 7. So you should have 7 rabbits there, okay? 2R equals 14, then 2 times 3. But this is a more advanced method. We're not going to study here right now. It's it's pre-algebra math, okay? So let me stop here. I wish you have a good weekend.